Why mainstream renewable power? We want that renewable power becomes the mainstream resource of energy. Therefore, we have chosen this name. A little bit of background to our company, Mainstream Renewable Power. We founded in 2008 Mainstream after the sale of Electricity. Electricity is similar to Mainstream, a wind farm developer, developing wind farms on and offshore. Electricity was sold to E.ON on SSE in 2007 and 2008 for around 1.8 billion. That was a really high price, a great one. Unfortunately, I didn't have so many stakes in it at that time. However, most of us, we believe that we can do it much better and much faster being an independent small developer and not a big utility. So we have chosen then in 2008, let's do it again. So we have established then Mainstream Renewable Power as a developer on and offshore and solar, so therefore we call Mainstream Renewable Power, not Mainstream Wind Power. So far, we have worked heavily on our pipeline, development pipeline, which looks quite good, I'd say. It's offshore wind in Europe, in Scotland, UK, and Germany. We have around 5.6 gigawatt. We are developing only offshore in Europe, but onshore, we develop in the US and Canada, so Northern America and Southern America and Chile, and in South Africa. You see the numbers here. So that needs a lot of stuff and a lot of money. We are currently around 120 staff worldwide, and we have collected so far money of around 125 million. Who owns this great company? It's Eddie O'Connor, our founder and CEO, former founder and CEO of Electricity, as mentioned. Staff and management are heavily involved in Mainstream, and private investors, mainly from UK and Ireland, and Barclays Capital invested at the very early stage into our company. So why offshore? My presentation focus mainly on offshore wind, not on onshore. And what I would like to do is to present you the main figures around offshore, and then coming to our projects, not to make huge advertisement on our company, but showing how a offshore project looked like and how one developed an offshore project. I think that might be very interesting for all of you guys, because offshore wind is a new technology and a new development, and it's not only just taking an onshore turbine and putting it into water. It's completely different. That's what mainly everyone thought 5 years ago or 10 years ago, but that's not the case. So why offshore wind? Why do we do this big development and try to tackle all the challenges? We believe that is the biggest development potential of renewable energy technologies. That is the key technology with whom we can make the difference to other technology in terms of replacing conventional and nuclear energy. Because we're building huge power plants outside in the North Sea and the Baltic Seas and everywhere else. So this is for us the key technology to replace conventional and nuclear energy. We offer large scale and reliable capacity, because the wind is blowing somewhere every time. It depends on the jurisdiction, of course. But at the end of the day, it blows mainly all of the time in the North Sea and in the Baltic Sea. So reliable capacity. A huge argument always against renewables, because they're not reliable. Offshore wind is reliable, and if you have a smart grid, it's nearly 100% reliable. We believe that with this support schemes and legal frameworks we have currently in Europe, we can build a huge pipeline at these days, because we have the support, the political support, and which enable us to foster these new technologies. And at the end of the day, I believe, and I think this is common sense, that offshore wind and wind in general, but mainly offshore as a key fuel, will be the key fuel for the European offshore grid infrastructure. But I come at the end of my presentation to this. Some figures. Status today, more or less 3,000 megawatts installed in 45 wind farms with over 1,000 turbines. Average size is today 3.2 megawatt in 9 European countries, more or less all the North Sea countries and Baltic Sea countries. On in a normal year, we produce 11. These turbines produce 11.5 terawatt hours of electricity. That's the EWEA figure, the European Wind Energy Association figures. All these are European Wind Energy Association figures. In 2010, we have installed in total 308 turbines with 883 megawatts, which is worth some 2.6 billion. So it's really big money invested. What is what do we believe for 2011 and beyond? 10,000 to 2,500 new installations in 2011. This is what we expect. 10 wind farms totaling 3,000 megawatt currently under construction, so a lot. And in total, we have already a consented pipeline of 90,000 megawatt. So this is consented already and will be under construction within the next years. Conditions. Conditions are rough. The North Sea is pretty rough. Baltic Sea is better, but not really strong wind. So the North Sea is really the key for us. The development started with small sizes. So wind farm sizes were around, the average wind farm size is 155. But the tendency is definitely to go to bigger power plants. So the average size will be, within the next years, 500 megawatts, definitely. Water depths. They started very close to shore and shallow waters. I mean, shallow waters, 17.4 is not really shallow, but it gets deeper and deeper. Under construction average today already is 25 meters. And for Germany at least, the average will be within the next years definitely 40 meters. Same for the UK, the most important markets, UK and Germany. Distance to shore, we started closer to shore, obviously, but under construction is already an average of 35.7 kilometers. But none of the German offshore projects, for example, have a distance, such a short distance. The Alpha Ventus test field is around 40 kilometers offshore, and most of the projects will be between 50 and 120 kilometers offshore. The current biggest offshore wind farm under construction in Germany, Bad Offshore 1, is around 110 kilometers offshore in 40 meters water depth. So that is really something which is not easy, and you have already an impression, I believe, that this is different to onshore wind. So what is our target? What do we believe looks the offshore future in 2020, 2030? EU target. This is also a collection of national targets, and the EWEA number is 20 to 40 gigawatt by 2020. Germany will contribute with hopefully 10 gigawatt. So a little bit will be difficult. Germany believes in 2025, 2030, there will be 25 to 30 gigawatts. It all, you see, you can't really predict it precisely because it depends on the weather conditions, depends on lots of other elements. I come later or in the next slides to this. And UK is the leading country in offshore wind. Already today, it has the lead in installed offshore wind, and the round 3, which is the biggest development pipeline in Europe, has a capacity of 30 gigawatt, and in total 45 gigawatt are under in the consenting procedure and will be hopefully constructed by 2030, more or less. So lots of gigawatt into waters within the next 10, 20 years. And so I think there's no question that we are able to replace European-wide nuclear and conventional energy with offshore wind. That shouldn't be an issue. However, huge challenges. It is not easy. It's definitely not easy. It's a completely new technology. It's a completely new industry. Of course, there are experience from wind onshore, from oil and gas, so we learn from everywhere, obviously. However, it's not just mixing the two, it's something new. But that's interesting to be in this new industry, to build up something completely new. So I've listed here the main challenges. It's financing, obviously. It's grid connection. It's the wind turbine, new wind turbines. Transport and logistics, far offshore, deep waters, windy weather. Qualified staff, because it's new. They are not falling from the sky. We have to take some from onshore wind, from oil and gas, some new people. So qualified staff will be definitely an issue within the next year. That is already. Operation maintenance and availability. It's not that easy to go for operation and maintenance to 100 kilometers offshore wind farm when it's quite windy. So it's not like an onshore with your bicycle going to the wind farm and check the turbine. It's different. So financing, similar to PV and all the other renewable energy, there's a support scheme. In Germany, obviously, the feed-in tariff, which is currently 15 cents per 12 years. In UK, there are ROCs. It will take an hour, mainly at least, to explain what all these elements in the UK system are. However, it's roughly 18 cents in total, but a little bit more in 20 years of duration. There are pros and cons. The best, of course, obviously, the feed-in tariff is a guaranteed feed-in tariff, and you have your stable income. However, at this stage, it is not enough. And it's not because we want to make the big money here. We're talking of returns below 10% at this stage. And if you compare a big power plant these days, which has so many risks as offshore wind, with other renewable energy plants and also conventional, it's very difficult to find investors here. So this is recognized also at governmental level, saying, okay, we have to foster, we have to push this development, otherwise we won't get more into waters. So for the first years, let's increase it, that there will be an industry, that there will be a track record, that banks get comfortable in this, that technology will be proven, has a track record, and what is key. So already mentioned, the banks are really hesitant in these days. We have worldwide maybe 10 to 15 banks in general interesting in offshore. Doesn't mean that they invest billions, not at all. Their tickets are around 30 to 50 millions per bank. And if you remember the targets we have, and remember the investment you need, and you see the numbers also up there, that is not enough. So there must be new incentive, there must be different incentive, there must be support to build up this industry, that banks and investors get confident, because that's very easy, higher risk, high returns, and not high risk, small returns. So that's a quite easy thing, but we definitely believe in a reduction of costs, obviously, but same with PV and onshore wind. You start with not the most the less expensive technology. You start very high, and you reduce your cost over your experience and over the duration of deployment. So, for example, we are heavily involved in new innovative foundation technologies, which reduces cost, which will reduce cost. However, we have to have it into waters and then see whether it works or doesn't work. So within the next years, I'm very comfortable, and the industry itself is very comfortable with that we definitely reduce costs. But at the beginning, there must be some incentives. Anyway, so this is financing, a big thing here. Grid connection. For every new technology, renewable energy, it's the same issue. Congested grids in Europe. We need smart grids for large scale of renewables. New cable facilities are needed. Cable, there's currently a lack of cables. We have, for example, in the Baltic Seas, a wind farm fully installed. 21 great Siemens turbines, everything's in waters. Baltic 1 is the offshore wind farm called. But the cable is not there. Everything's good, but no cable. There was an accident in the factory, or there was a issue, whatever, so they couldn't deliver at the time. So they have to redo the manufacture of the cable. It takes long. It's everyone, as I said, it's new. It's not like we have done it for the last 20 years, so it's easy to produce, and we have enough cable on stock. No, it's new. So we have their wind farm, and it since end of last year, completely installed, finished. Cable is missing. So, issue. What can you do? You need the cable from the turbines to shore, obviously. Wind turbines, I've already mentioned, and you remember the current average size of the turbine is 2.3. And it will be definitely in the future much bigger. 5 megawatts it's a key number. 5, 6 megawatt will be the turbine size in future. They are in the Alpha Ventus test field in Germany. We have 12 5 megawatts turbine installed. They're running okay, but there's not already a track record. You have a track record within the next years when you see, okay, there's availability, machine is working, not high O&M costs. So turbines are on the market, and it's good that there's a new competition. At this stage, it's mainly Siemens and Vestas machines, some repower machines. However, not huge competition, but new players come on the market. GE is back on the market, Mitsubishi is coming, the Chinese are coming. And then for this technology, it's quite good, but because this opens up competition. And it's absolutely good for prices, and again, to reduce costs. Transport and logistics, harbor facilities, installation vessels, it's not really there. So we need new harbor facilities, big new harbors, completely different to oil and gas harbors or shipping or other harbors facilities. So obviously you understood the issues. And just running through some examples from our development pipeline and showing what does it mean in practice. So three groups of development: surveys, environmental surveys, design, etc., construction, and operation. You see here what we're doing there. Financing is, of course, a big issue. What we do as a developer, and what most of developers do, we start from greenfield development, so from scratch, going about consenting procedure, development, and to ready to build, and then looking for a big partner for investment into the turbine. So what you have to have as a developer, you should have all the skills in-house: design skills, environmental skills, health and safety, wind analysis skills. That's what we all have in Dublin, London, and Berlin. These are our 3 projects. These are the key markets: Germany and UK. Scotland is part of UK, obviously, but this is Scottish territorial waters. It's very important for Scotland. There was, mentioned before, the biggest round in UK is the round 3, with a total capacity of 33 gigawatt. There was a tender. We bid for one of the zones, the Hornsea zone, and we, as the only non-electricity utility, were awarded together with Siemens. So you see, all the others are utilities, but we were seeing, okay, we want to look at the whole life cycle, from development, electrical engineering, turbines, and construction. So our consortium is Mainstream as a developer, Siemens for the electrical kit and the turbine, and Hochtief as the construction company. But it is a joint venture between Siemens and Mainstream, but Hochtief is involved as well. So 4 gigawatt. Scotland, very close to shore, deep waters, very difficult, but close to shore, that's always good. Germany, that's our projects in Germany, a potential capacity of 3 gigawatt, of 1 gigawatt in 3 projects. Already mentioned, stable market, which is good. However, it needs to be improved. And what's our vision? At the end of the day, what I've mentioned, we need a European offshore grid infrastructure. And this is our vision of a supergrid. And this has to be started very quickly, because the idea is not point to point, like turbine, wind farm to shore, but the whole structure to make the transition from nuclear and conventional to renewable possible. So we believe, as a phase 1, a connection between UK, Germany, Belgium, and Norway as the battery, and running through with HVDC to Munich, for example, or North Rhine-Westphalia, because there is the place where the energy is needed. Support by governments, European governments. They have agreed on a memorandum of understanding, 9 European North Sea countries plus Norway, to see, okay, what are the hurdles at this day, where we want to go, what do we need for this? Let's make an agenda, let's make a plan to realize a supergrid. And I think that's great as a governmental support. What we as an industry believed, it shouldn't be a governmental project, it must be an industry project. So we as Mainstream initiated in 2009 the so-called Friends of the Supergrid, saying, okay, governmental support is there, now industry has to make the cooperation right, saying we support the idea of the supergrid and we can deliver. You see all these companies, whether it's Siemens or Hochtief or Prysmian as a cable manufacturer, they all are in the supply chain of building large-scale offshore wind with a European offshore infrastructure. Thank you very much.
That's a huge thing. You are building up offshore wind. I don't want to wait until 2050. I think it's too late for the supergrid. I think it must happen more quickly.
Phase 1 is 2020, so
yeah.
that's why I believe a phase 1 is so important.
Yeah. Do you have a question for Tilman?
Hi Tilman, my name is Andreas. Thanks a lot for your presentation. I like those maps, especially because it's giving a good picture. I have some questions. Question number 1 is, what is the limitation in the life cycle of a windmill? So after those 20, 25 years, what is going to happen with the windmill? Is it going to be recycled or what happens?
Should I respond immediately?
Yeah, sure.
Because otherwise we forget the question. It's very similar to your health care and to your care of your car. If you treat yourself well and check your car regularly, you have a longer lifetime. Same with the turbine. O&M is very important. And so the manufacturer believe 20 to 25 years. And our consensus, for example, in Europe is between 20 and 25, so similar to the lifetime of the wind turbine. However, if the turbine runs perfectly after 25 years, there's no need to decommissionize the turbine. So proper O&M is important. Then maybe you get to 30 years. But actually, you don't know it these days because we don't have the experience. But what we calculate is 20 years at least, 25 average, and hopefully longer.
And the second question is, what is the percentage of loss of the current coming from the North Sea to Munich, for an example?
With HVDC, and that's the key, that it's HVDC and not AC.
It stands for high voltage direct current.
That's correct. The losses are minimal. So it's really 0 point something. It all, of course, depends how far the offshore wind farm is. For our one, you remember, which is 140 kilometers, a little bit more than the one closer to shore. But with HVDC, this new HVDC VSC, to be absolutely correct, that's a new cable technology already installed in the far offshore wind farms in these days. Extra developed and designed for large distances. And so that's the huge benefit in comparison to AC. So losses is an issue, but with HVDC, with this new technology, it's absolutely reduced.
Thank you.
Welcome.
Another question? All right. Thank you very much, Tilman. You get your green design speaker gift. Thank you very much for coming on our green stage.